friends, in previous video we discussed knapsack problem from greedy method. Now here we'll also going to discuss one more topic from greedy method, that is spanning tree. Now here we're going to discuss what is the definition of spanning tree with one example, and we'll also going to discuss one more topic, that is MST, that is minimum spanning tree, and how we going to calculate cost for the spanning tree, that is nothing but the minimum spanning tree, with one example and definition. So let's start. Let's understand what is mean by spanning tree. Now let's understand this with one example. Now this is an undirected graph. Now what is mean by graph? Graph is nothing but the connected to every vertex. Now this A, B, C having the vertices, and this vertex is one vertex is connected to the another vertices from the edges. So this is called the edges AC and AB, etc. So this graph is having the three edges and three vertices. Now spanning graph, that is spanning tree, can be formed by from this original graph only. So same we are going to consider this graph only, and by using this graph we can having the different kind or multiple kind of trees, but having same vertices. That is, if this graph is included the three vertices A, B, C, if I remove this edge AC, so I'll get the same subgraph. So spanning tree is nothing but the subgraph, but having the same vertices. That is it only remains the three vertices as it is. Now similarly, if I delete this edge, so I'll get the subgraph of this graph. Similarly, if I delete this edge, I'll get the subgraph of this graph. So I can get the multiple graph from this graph. That is nothing but the spanning tree. Now here, so what is mean? So it is a subset of edges. Now if subset of edges, that is edges doesn't matter, I can remove the edges, but vertices remain the same, and which is acyclic, where every node of the graph is a part of the tree. Acyclic, that means what? The graph must not include any cycle. Now the subgraph or spanning tree is a tree-like subgraph. Now what is mean by tree? That is, it is connected undirected graph, and it must be include all vertices of the graph. That is, it must be have to include, if this graph is having the three vertices, then the spanning tree also having the three vertices. But the what about the edges? Edges can be n minus 1. Suppose n is the vertices. Now here there are three vertices, and if I minus 1, so 3 minus 1 becomes a 2. So every subgraph having the two vertices in the spanning tree. Now let's understand it definition. So spanning graph is a subgraph that contains all vertices of the graph. Now consider this graph. Now this graph is having the vertices from 1 to 3, 4, 5 to 6. Now all these vertices, if I remove the any edges, because spanning subgraph is connected. Now definition of spanning tree is include which is connected and there is no cycle in a tree, becomes the spanning tree. Now you can see here 5 to 4 and 2 to 5 become having the some cycle, because, and if I remove this, I'll get this graph. So after removing these edges, I'll get the subgraph of this, and this graph become a spanning tree. But this graph doesn't have any cycle, and it includes all the vertices 1 to 6. Now edges, and if I calculate the edges, that edges becomes the n minus 1. Now, so spanning tree is defined as a tree-like structure of subgraph which is connected graph which include the all vertices of the edges, and the subset of the edges of the graph forms a tree, that is acyclic, where every node of the graph is a part of the tree. So that is what the spanning tree. Now let's understand what will be the properties of spanning tree. The first properties is what? The vertices of the graph and spanning tree must be same. That is, all vertices must be included. Next, number of edges in the spanning tree which is equal to 1 less than total number of vertices. That is, the edges become the total number of vertices minus 1, because I don't want any cycle in that spanning tree, so I can delete the edges, but the total number of edges remains v minus 1, that is the all vertices minus 1. Now the spanning tree having the property like it should be acyclic. There will not be any cycle in the tree becomes the spanning tree, and we can calculate the cost. Now every edge is having the weight, it having the weight or cost. Now it defines a sum of edges weight. So if I make the sum of weight, it becomes a weighted graph. It becomes the weighted graph, or if I am going to calculate that sum of all weighted graph. And next, you can form so many possible spanning tree or multiple spanning tree from the graph. So these are all the properties of spanning tree. Now here we know that spanning tree is what? Now spanning tree is having all vertices of subgraph, and I don't want the cycle in that graph become the spanning tree. Now minimum, that is if the graph is having the weighted, and if I make the cost or if I make the sum of all weighted, that sum must be minimum, that becomes the minimum spanning tree. Let's understand it with one example. Now suppose consider this graph, and this is an undirected graph. This graph is having the weight of that edges. Now I'm going to form some spanning tree, multiple spanning tree, but the vertices must be included. Suppose if I included like this dark line vertices, dark line all vertices and the edges, so it includes all vertices, but I can exclude the edges. But it doesn't form the any cycle. There is no cycle, but it can cover all vertices. So the cost of this particular tree becomes the 4, 5, 2. That is nothing but the 4 plus 5, 9 plus 2, that is the 11. Now I can consider one more, and consider one more subgraph of this graph which included all vertices having the cost 4 plus 1, 5 plus 2, that is the 7. So this graph becomes the minimum spanning tree, because the weight of this graph is the minimum, that is less than 11, so it becomes a minimum spanning tree. Let's consider one more example. Now this is the graph. Now I can form the many subgraph like this, and the cost of this spanning tree becomes the 2 plus 3 plus 3 plus 5 becomes the 13, and this graph includes the all vertices. Similarly, I have one more spanning tree which having the all vertices, and the cost is 2 plus 1 plus 3 plus 1, that is the 7. So this example of MST. Now here we are going to solve this, or we are going to calculate the cost of this graph. So I'll get the minimum cost. Selected minimum cost age, that is this is the one. Now one is the very minimum cost or weight, so I'll selected one. Now after one I can select two. If I selected 2 age 6 to 5, even if I can select this age of vertices 2 to 8, after 2 I can select 4, that is vertices from 2 to 4, 2 to 5. Now here there is no any cycle is formed. Now after 4 I can select this 4 also, 0 to 1, because I have to include all vertices, because I am going to form the subgraph, that is nothing but the spanning graph or spanning tree. So I must have to include all vertices. Now after 4, fifth is not present. If I select this 6, it becomes the cycle, and spanning tree doesn't have hold any cycle. I don't want any cycle. So after 6, I can select this 7 also, because I want the vertices 3, because spanning tree include all vertices. Now after 7, I cannot select this 7 because if I select it, it becomes a cycle. So I am going to ignore this 7. Now after 7, 8. Now I can include this 8 because I want to make the connected graph, because the spanning tree hold connected between every vertices and it must have include all vertices. Now after 8, this 8 is not selected because this 8 forms a cycle. So this 8 is not going to consider in this graph. Now after 8 I can select 9 because 3 to 4 because I want the vertices 4 because of connection or because of connectivity. Now here you can see 0 to all vertices 7, 6, 5, all vertices get connected, and I form the minimum spanning tree, and this becomes the subgraph of graph. So the minimum cost becomes the 37. So this is all about minimum spanning tree. Let's understand the definition of minimum spanning tree. So minimum spanning tree is defined as a spanning tree only that has the minimum weight among all possible spanning trees. This is all about the spanning tree and minimum spanning tree. Now in the next video we are going to discuss one algorithm which is called as a Prim's algorithm. Thank you.